Okay. If x is 3.1, then this expression is you get 3.1 plus 2 over 3.1 minus 3, which is 5.1 over 0.1. How many 0.1s do you need to make 5.1?
51.
You what?
51.
Yeah. Of course, there's a rule for dividing by whatever, but you can count it. 0.1, 0.2, 0.3, 0.4, well, you need 10 of them to get to 1, right? They're going to need 10 more to get to 2 and 10 more to get to 3. It's going to get monotonous. 10 more to get to 4, 10 more to get to 5. That's 50. And then you just need 1 more to get to 5.1. Okay? If you don't understand that clearly about division, think about it until you do. So that's 51. That's a pretty big number. Okay? What if x is 2.9? Well, then y is
50. Is that 5.1 or 51?
2.9, well, 2.9 plus 2 over 2.9 minus 3, which is 4.9 over negative 0.1. Well, you know it's going to give you a negative number, same as negative of 4.9 over 0.1, and that's negative 49. So what's your graph going to look like? You got a 0 at x equals negative 2. You're going to have a y-intercept. And that's going to be 0 plus 2 over 0 minus 3, which is negative 2/3. So now, we begin to construct a graph. Okay, we've got a 0 at negative 2. There's the point negative 2, 0. I'll just indicate that was a negative 2. We've got a y-intercept of negative 2/3. And then it's undefined at x equals 3. Okay? So at 3, which would be over about here, I'm going to put a big old circle here. Clearly a circle, meaning that there's a hole there. Okay? In other words, you don't have a value when x is 3, so we're not going to go through that point. And as a matter of fact, there's not going to be anything above or below that point because there's no value when x equals 3. So we can make a vertical dotted line at x equals 3. We can say that there's no graph point on this line. Okay? Cannot have a graph point on this line because that line is where x equals 3. And I don't know how I got more than that. Okay. Well, my equal sign wasn't very good. Let's make sure. Got that. Okay. Okay, because if we plug in 3, we get an undefined value. There is no value, no y value. Okay. Looking at points close to 3, one on this side and one on that side, we find that if we go to the right, we got a point all the way up there at 51. Okay? Now, if this is negative 2/3, 51 is up there through the ceiling someplace. Okay? And I'm just going to say, okay, way high. It's way high here. Then we got negative 49 over here. That's way low. So we can say that it's way up there. It's much higher than I can draw here, but I'm going to put a point there anyway. Okay? And -2.9, -49 is way down there, much lower than we got it down through the floor. Okay? Actually, maybe about at the floor. You get the idea. Okay? So it's much lower than I've drawn it. That's much higher than I've drawn it, but it's still going to allow us to do what we need to do. Okay, we can then test to the right of this point. Let's just choose x equals 4. That's an easy number. Y would equal 4 plus 2 over 4 minus 3, which is positive over positive, which is positive. Okay, so we know that the graph has to be positive all the way to the right of x equals 3, and that's consistent with what we got here. To the left of -2, let's just take -3. This is negative over negative, which is positive, so we know it's positive here as well. And then between here and here, we know from the y-intercept, I just went ahead and picked x equals 0 because that's always convenient. You get -2/3, you get your y-intercept, which makes the thing negative on this intermediate interval. So what happens is you've got positive values on this side. You got positive values on this side. You got to go through your 0 here and go down to here. But then all of a sudden, you're way up here. Okay? Now there's a little more to it. I'm not going to explain why it does this. But the value of this thing is going to kind of flatten out when you're up here. I'll explain it in a minute, but I'm not going to explain it right now. So it just kind of does this. I didn't draw that very well. It keeps approaching this vertical line as an asymptote. Because, why? Well, making x equal 2.9 made the denominator small. Okay? And the numerator is still pretty close to 5. The denominator is getting small. That makes this number big. If we let x equal 2.99, your denominator would be 0.01. And to count to 4.9 or something close to that by 0.01s, going to be about 490. It's actually going to be pretty close to 500. Okay? It's going to be negative. The closer x gets to 3, the further you got to go down, the bigger that negative number gets. Okay? It gets less, but it gets less by getting to be a bigger negative. Okay. To the right of this x equals 3 line, same thing happens. You're way up here, and you're going to come down kind of like this. Okay? And if x gets closer and closer to 3, this value just gets bigger and bigger, because just like we got a small denominator here, denominator is going to get smaller and smaller as you get closer and closer to 3, and this number is going to get bigger and bigger. It's going to get no limit to how big it gets. So this graph goes up and up and up and up, gets as big as you want it to get, and then even bigger than that. No matter how big you think it gets bigger. Okay? So it's almost vertical here, almost vertical here. It never quite gets to the x equals 3 line. That make sense? Okay, well those two behaviors are behind the behavior of most, well, of your rational functions. And polynomials behave, as we said. We'll do more with this after break, but this is what I want you to understand for the midterm. Okay? I tried to explain it in very clear terms. You gotta watch the videos 100 times, well, you're probably not gonna make it because you don't have that much time. But if you watch them, and take careful notes, and think about what you're doing, and then look at what your text, I'll give you some correlations in the text if I've got it, and some correlations on them and on, in case you don't understand it all. Now, the one thing you don't necessarily understand is why the graph does this here and does this here. So let's just talk about that. If x is really big, okay, like if x is equal to 100, what do you get? What's the value of y? Well, write it out and see. X equals 100. What's the value of y?